Welcome to this lesson on balancing chemical equations. Today, we'll explore one of the most fundamental concepts in chemistry, the conservation of mass in chemical reactions. Understanding how to balance atoms on both sides of chemical equations is essential for anyone studying chemistry. By the end of this video, you'll have a clear grasp of why balancing equations matters and how to do it systematically. Every chemical equation must follow the law of conservation of mass. This law states that matter cannot be created or destroyed in a chemical reaction. What does this mean in practical terms? It means the total mass of reactants must equal the total mass of products. During a reaction, atoms are simply rearranged into new combinations. No atoms are created, and no atoms disappear. They just form new bonds with different atoms. This principle is the foundation for why we need to balance chemical equations. Let's look at a simple example to understand the difference between unbalanced and balanced equations. Consider the reaction where hydrogen gas reacts with oxygen gas to form water. On the left, we have the unbalanced equation. Hydrogen 2 plus oxygen 2 yields hydrogen 2O. Notice something is wrong here. On the right, we have the balanced version. 2 hydrogen 2 plus oxygen 2 yields 2 hydrogen 2O. The balanced equation correctly represents what actually happens in nature. The coefficients in front of the molecules make all the difference. Let's count the atoms in our unbalanced equation to see why it's incorrect. In the unbalanced equation, hydrogen 2 plus oxygen 2 yields hydrogen 2O. Let's examine the reactant side first. We have 2 hydrogen atoms and 2 oxygen atoms. Now look at the product side. We have 2 hydrogen atoms but only 1 oxygen atom. This creates a problem. We started with 2 oxygen atoms, but we ended up with only 1. This violates the conservation of mass. Atoms cannot simply vanish. This mismatch tells us the equation needs balancing. To fix an unbalanced equation, we add coefficients in front of the chemical formulas. Coefficients are whole numbers that multiply the entire molecule. In our example, we place a 2 in front of hydrogen 2 on the reactant side and a 2 in front of hydrogen 2O on the product side. This gives us 2 hydrogen 2 plus oxygen 2 yields 2 hydrogen 2O. There are 3 critical rules to remember. First, coefficients multiply the entire molecule. Second, never change the subscripts within a chemical formula, as that would create a completely different substance. Third, always use the smallest whole numbers possible for your coefficients. Now let's verify our balanced equation by counting atoms again. In the equation 2 hydrogen 2 plus oxygen 2 yields 2 hydrogen 2O, let's start with the reactants. The coefficient 2 in front of hydrogen 2 means we have 2 times 2, which equals 4 hydrogen atoms. We have 2 oxygen atoms from the oxygen 2 molecule. Now for the products. The coefficient 2 in front of hydrogen 2, O, means we have 2 molecules of water. Each water molecule contains 2 hydrogen atoms and 1 oxygen atom. So we have 2 times 2 equals 4 hydrogen atoms, and 2 times 1 equals 2 oxygen atoms. Perfect! 4 hydrogen atoms on each side, and 2 oxygen atoms on each side. The equation is balanced. Let's learn a systematic method for balancing any chemical equation. Step 1. Count the atoms of each element on both sides of the equation. Make a list to keep track. Step 2. Identify which elements are unbalanced. Look for elements where the number of atoms differs between reactants and products. Step 3. Add coefficients to balance one element at a time. Start with the most complex molecule or the element that appears in the fewest compounds. Step 4. Recount all atoms and verify the balance. Make sure every element has the same number of atoms on both sides. If something is still unbalanced, adjust your coefficients and repeat the process. Now it's time to test your understanding with a practice problem. Here's an unbalanced equation for the combustion of methane. Methane plus oxygen gas yields carbon dioxide plus water. The chemical formula is CH4 plus O2 yields CO2 plus H2O. Try applying the step-by-step method we just learned. Count the atoms on each side. Identify which elements are unbalanced. Add appropriate coefficients one element at a time. Then recount to verify your answer. Pause the video now and give it a try. When you're ready, you can check your work using the balancing method we covered. With practice, balancing equations will become second nature.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.